Hi guys, welcome to physics lesson. Today we are going to talking about the free fall acceleration and gravitational force. And when we define mg as the weight of an object of mass m, we refer to g as the magnitude of the free fall acceleration. Now we are in a position to obtain a more fundamental description of g, because the force acting on a freely falling object of mass m near the Earth's surface is given by Fg is equal to g times mass, small mass, times the small mass is mass of the object, and mass of the Earth over radius Earth square. And weight formula is equal to mass times gravity. And we can equate mg to this force to obtain. And mg is equal to g times mass of the Earth over radius Earth square. And g is equal to universal gravity constant times mass of the Earth over radius Earth square. You see, gravitational field depends on the capital G and gravitational constant times mass of the Earth over radius Earth square. It not depends on the mass of object. Now let us consider an object at the altitude of h above the Earth. This formula we are using if our object is near the surface of Earth, but if there's an altitude, what will be g? This gravity is near the surface, we know g will be gravitational constant times mass of the Earth over radius Earth square. From this formula you can find gravitational field. But if there is an altitude between the object and surface of Earth, there is a h altitude, and formula will be g times mass of the Earth over radius Earth plus height square, not only radius Earth square. And distance between the object and the center of Earth, the distance will be radius Earth plus height square. And gravitational field near the surface of the Earth will be bigger than gravitational field far away from the Earth. You can say g and the distance is inversely proportional. If we increase altitude, g will be decreased. And there's a table, free fall acceleration g at various altitudes above the Earth's surface. You can see altitude in kilometer. If altitude is increasing 1 kilometer, 1000 kilometer, 2000 until 50,000 kilometer. When the altitude is increasing, you will see g is decreasing. An example: determine the magnitude of the acceleration of gravity at an altitude of 500 km. And g will be 6. We'll use this formula: g times mass of the Earth over radius Earth plus 8h square. And g is constant, 6.67 times 10 power minus 11. Mass of the Earth is also a constant, is here. There's a constant mass of the Earth, radius Earth, and g universal gravity, 5.98 times 10 power 24 over 6.38 times 10 power 6 plus 0.5 times 10 power 6. I convert kilometer to meter, and g will be 8.43 meter per second square. Another example: at what altitude above the Earth would acceleration of gravity be 8 meter per second square? We will use same formula. From the altitude, g will be g times mass of the Earth over radius Earth plus h square. Now I know gravitational field is 8 meter per second square. I know g is constant, is here, and mass of the Earth is constant. I know radius of Earth. I will find height. I will put in the formula all given, and height will be from the mathematical process. H is equal to 690 kilometer. An example: calculate the acceleration due to gravity at the surface of the moon. The moon's radius is about 1.7 times 10 power 6 meter. and its mass is 7.4 times 10 power 22 kilogram. And this formula is same for all planets, but in this formula for Earth, but if our planet is Moon or Jupiter or another planet, we will use mass of the our planet. For example, our planet is Moon, and formula will be gravity Moon is equal to G times mass of the Moon over radius of the Moon square, not radius Earth. And G is also same for all planets in everywhere, 6.67 times 10 power minus 11. Mass of the Moon is 7.4 times 10 power 22 kilogram over radius of the Moon 1.7 times 10 power 6 square. And G gravitational field on the Moon will be approximately 1.7 meter per second square.